So users may be on or off network. During the pandemic, users were working from home, connecting through the Zero Trust Exchange to their private applications. We had visibility and control of those users, the applications they're accessing, and the endpoint. However, when they move back into the office and they're placed back on the network, the actual level of security drops. So how do we provide the same consistent user experience, the same control of what those users are able to access and visibility of what those users are accessing, providing that zero trust network access and accessing those internal applications whilst on the internal network without tromboning traffic out to the Zero Trust Exchange and back in again, which may consume additional bandwidth or may add additional latency. So by providing a private service edge inside the office means that we can provide that zero trust network access policy local to the user and local to those applications, increase the user experience and decrease the latency. So if we think about the configuration for this, we're going to deploy a private service edge in those data center or office locations. The software updates come from Zscaler to that service edge the same way that they would for an app connector or any other part of the Zero Trust Exchange provided by Zscaler. Those Zero Trust Exchange functions are then provided by that private service edge local to the user, and this service edge is single tenant dedicated to that customer inside their architecture. We'll deploy private service edges in pairs. Each private service edge has 500 megabits per second of peak throughput, so we will deploy additional service edges which will be load balanced to provide greater throughput. The private service edge is provided as a virtual machine image for deployment in VMware, Microsoft Hyper-V, AWS, Azure, GCP, or as an RPM package that can be installed on top of enterprise Linux. So how does this look? So a user in a branch office, say, will connect over the MPLS connection to that private service edge. And that private service edge is connected to the Zscaler cloud to receive its policy updates and information about the configuration for the cloud service. That private service edge will then apply that same policy and connect users to those applications either through the connector in the data center or a connector in a SaaS infrastructure as a service platform. If we think about remote users, we might also deploy a private service edge which has an internet point of presence. So there will be a firewall that allows connectivity into that private service edge. And so remote users can connect over the internet through the firewall and into that service edge. So that service edge may be a customer data center. It may also be infrastructure as a service. But the reason we deploy that private service edge is to give a point of presence, perhaps in a location where Zscaler's service doesn't extend normally, or to provide data regulatory reasons to keep policy in the customer's network. So the user connects to that private service edge over the internet, and that private service edge again functions as part of the cloud and provides the access policy and stitches the connections together to those applications through the connector in the data center or the connector that might be an infrastructure as a service over, say, an express route or a VPN. And so to provide that universal ZTNA for the hybrid workforce, the home office user working remote would connect over the internet to the private service edge. The branch office user would connect over their MPLS connection to the private service edge, and then we would stitch together those connections to provide access to those applications. It is also worth noting that these users can continue to use all of the points of presence from Zscaler's public cloud. So the private service edge become an extension of the public cloud, which is dedicated to the customer instance.